Good afternoon. I would like to talk about a subject which is close to our heart and we found rather surprising over the past few years, which is how you identify bottlenecks in projects and in production environments. And to start off with a conclusion, the good news is that you're wrong about where your bottlenecks are. Okay, and we'll run through that point by point. What we're going to do is just do a brief introduction, and then I'm going to give you a few cases that we've lived through these past few years, the lessons learned from all this, and then a quick conclusion. My name is Philip Marris. I'm the CEO of Marris Consulting. I've been practicing both lean and theory of constraints together simultaneously for over 25 years. I've worked in over 100 different companies in France, Europe, and the rest of the world. And I wrote a very boring book about how to use the theory of constraints in manufacturing. We also do quite a lot of awareness and marketing around the theory of constraints and around theory of constraints plus lean, or TLS, Talk plus Lean plus Six Sigma, both on YouTube videos, on our websites, and on Scoop It, Facebook, and so forth. So if you want to hear more or read more, look us up in all those places. We're going to talk about production and projects, but it's all based on our company's experience. And this is not all kinds of environments. And in particular, I'm not going to talk about what happens in sales and marketing, what happens in purchasing, what happens in distribution. And I'm not going to address at all the management attention constraint that people sometimes talk about in the theory of constraints. The main point is that if I go back 25 years or 20 years or 15 years with regards to work in the theory of constraints, people would ask us to implement the theory of constraints in their factory. They would call us in and they'd say, come here is our bottleneck. And they were right. It was their bottleneck. Okay, so it was fairly simple. We had to implement the theory of constraints. We knew where to start. Step one, identify the bottleneck, done. And off we went. Now, over the past 5 or 10 years, when we get called in to implement theory of constraints, they say, yes, we want to do theory of constraints. Come here, this is the bottleneck. And 8 times out of 10, they're wrong. Okay, and of course, that's important because if you don't know where the bottleneck is, the implementation of the theory of constraints is going to get very strange and go all wrong. Okay, and so that's basically what I want to talk about today. And to give you, before I talk conceptually about the lessons we've learned, I'd just like to go run through some examples of these past few years. A very large European and world leader in manufacturing of steel, one of their mega factories with nearly 3,000 people, wanted to implement the theory of constraints. They were convinced that it was their beautiful, expensive rolling mill that was the bottleneck. So they said, this is the bottleneck, look at it, isn't it beautiful? And unfortunately, in fact, what turned out to be the constraint were the heat treatment furnaces. So it wasn't the big, beautiful machines, it was these rather boring ovens that turned out to be the constraint. Another example, in one of the top 6 pharmaceutical companies making drugs for animals, they had a research department with 280 people, and they wanted to implement theory of constraints, critical chain, for their project development. And they said, well, obviously our constraints are that these key top scientists, these 19 people, that are the capacity constraint and determine whether or not, or how many new drugs we can develop. And please don't talk too much to their thinking. And please don't disturb them. These are the big thinkers, and that's the capacity constraint. It seemed fairly convincing, and it seemed like a healthy situation. But when we went through and implemented critical chain and looked at what was happening, we found out that in fact the capacity constraint of that organization was not there at all. It was in the industrialization process, a group of only 9 people whose job it was to define the industrial process to manufacture these new drugs, and they were the capacity bottleneck. Why was that? Because about 5 years previously, they'd taken the decision to outsource about 50% of the new developments. They had lots and lots of new ideas, So they were feeding their factories with lots of production, and they decided that 50% would be outsourced to external manufacturers. So in fact, the work of those 9 people had been multiplied by about 10, because instead of just industrializing things for their own factory, they had to choose manufacturers throughout the world, in India, in Turkey, in Brazil, and so forth, audit them and manage them, and their workload had been multiplied by about 5 or something, and their resources only by about 2. So they were the bottleneck, which led to the crazy situation where they spent millions developing drugs. They got the patent out on it, which was running, ticking out, and yet they just weren't making it and therefore not selling it. Another example, this one in aeronautics, was a strange case about a 400-person factory in France, and they were convinced that they were overdue, they had lots of problems, and they were convinced that their 5 main most expensive machining equipment were the constraints, the capacity constraints of their system. We looked around this factory, and very quickly we saw this big pile of work in process. And we said, well, what's this? Well, this is waiting for quality control. And in fact, in this case, it wasn't these machines that were the bottleneck, it was their quality control process that was, in fairly spectacular proportions, since over a third of the work in process was waiting for quality control. And the reason probably they'd missed that was that they weren't sitting in front of their computers looking too much at their ERP system, which was telling them things which were not true, in fact, concerning the load on those machines. And the quality control, since it was an indirect function, wasn't even in the data. There was no capacity management of quality control in that part of the system. And so they didn't see it. Their ERP didn't see it, and therefore they ignored it. Okay? And so that's another case where they were wrong about where the bottlenecks were. Yet another factory in aeronautics in Europe, a 700-person factory making very sophisticated ball bearings for helicopters, for airplane engines and stuff. Again, they called us in, we want to implement theory of constraints. We thought about this a bit, and the machines are these ones. And we went over to have a look at these machines, and we did a very rough calculation of what the load was on these machines, and we just couldn't work out what the problem was. And in fact, they confused the workload with the urgency. That's to say that these machines came right at the end of the process and were in fact used to correct any quality issues that they might have had. Okay? And they had sufficient numbers so that they were often asking for these machines to do a piece of rework at the very last moment when the order was due or overdue. And so everything that went through those machines was urgent and late. Okay? So they thought that must be the bottleneck. Okay? But it wasn't in terms of capacity. It just needed to be there like a fire engine ready to help. But the average load during the month was fairly low. So once we'd sorted that out and said, okay, it's not there, where is it? And they said, well, it must be our very expensive milling machines. And again, we did a quick calculation, and it didn't make sense that it was those machines. So we thought some more. And in a corner of the factory, in a complete opposite corner in the shadows, nobody even thought of talking about it, was this little set of 2 or 3 machines in the corner that made a not very important part of the product. And because of lack of management attention, in fact, it had become the bottleneck. Okay? And well, that was another surprise for them all. In fact, it was so strange for them that they didn't believe us when we said so. And what we did was cross the production and the productivity of those 3 machines over a whole year, month by month, and compare it to the sales of the company. And there was a perfect correlation. It was just obvious that if those machines had a good month, the company made money. When they broke down, the company had a problem. Okay? But we needed that data because they just couldn't. They couldn't admit that these little machines that were not important could be the bottleneck of the company. Yet another case in steel manufacturing business, another large factory of over 2,000 people. One of the most challenging bottleneck identification cases that I've had, in fact. I was getting desperate because I looked around. What we do is try to look for big queues of work in process to find where work is piling up, and I couldn't. I kept looking at the data, and there seemed to be lots of things everywhere, and I was starting to get desperate as to where it could possibly be. So what we did, we went down onto to the shop floor, or again we went down to the shop floor to try and work out what was going on, and I started asking more and more people, what do you think, where is it? And in particular I asked the people who at expediting, where do you go and find your products when they're late? And several people gave me the same answer, and I went and had a look and thought about it. It was manual quality control. These were big sheets of metal, 20 meters long, 4 meters wide, and so forth, stored all over this huge factory. And in fact, there was a mobile team of about 16 people that went around with things that looked like metal detectors and checked the quality of the product. Okay, but they went to where the products were, and they went all over the place. Okay, and so their queue process was important, but we had to add up all the work that was waiting for them. It wasn't anywhere evident in the information system. Okay, but once again we got that, worked that out. We added up all the stuff, all the work that needed to be controlled by these people, and again it was very obvious that that was the case, and we'd found them. Okay, but it was strange because the queue was spread all over the place. Another case, which shows how you can create a bottleneck with a decision. This is one of the leading automobile equipment manufacturers in the world, very well known, very efficient, a very highly regarded company. And one of their divisions made alternators for cars with factories all over the world. And back in 2012, the price of rare earth metals was going sharply up, doubling, tripling, multiplied by 10 and so forth, to the point where their alternators, which were designed with rare earth magnets, the cost of the magnets in their products was getting unbearable or completely excessive. And so they decided to replace the rare earth magnets by normal magnets. Normal magnets are about half the power of a rare earth magnet, so they just needed to have two normal magnets where there was one rare earth magnet. Okay, for the moment it all makes sense. Yeah, they were going to save quite a lot of money in purchasing, and the product was going to be just as efficient, so no big deal. There was just one problem. Throughout all these factories in the world, the processes were exactly similar. Okay, and one machine cut the slots in the stator here so that you could insert the magnets. Okay, beautiful, well-oiled lines, working a nice even tempo, nearly balanced, and suddenly one of those machines had to work twice as much as before. Okay, so the production volumes, the throughput of the entire division was going to be reduced by 50%, halved, simply because of that purchasing decision. Because all of a sudden, one of the machines in their process, of about 15 machines to make these things, was going to have to do twice as much work. Okay. Luckily, we caught that just in time, and they managed to invest and double their machines, put 2 machines in the line where there was 1. But very nearly, nobody noticed. So that's how, in fact, watch out, even if you think you've got rid or identified where your bottlenecks are, some decision, often completely legitimate and intelligent, can lead to redistributing the workload throughout the factory and creating a new bottleneck violently and spectacularly. And this can catch companies off guard. So, what are the lessons learned with regards to this? What have we seen or learnt over the past 5-8 years, where this aspect of things has been getting stronger and stronger? I think that one of the main messages is be careful. The main difference between an adult and a child is the price of your toys. Okay, and people tend to confuse where the bottleneck should be and where it is. Okay, obviously, to keep it very short, a good bottleneck or not too bad bottleneck is a very significant, expensive piece of equipment, right? A machine you're not going to buy 3 of if one will suffice. Okay, so big expensive machine sounds like a good idea, least bad place to have your bottleneck. Okay, so people tend to think that these nice big spectacular looking machines, expensive things, are their bottlenecks. Okay, that's where they should be. That is not necessarily where they will be. And if you cut costs in the wrong places or do something silly, you will find that in fact your bottlenecks end up being somewhere completely different. And you won't realize that because your attention is focused on your big, beautiful machines. And you won't, by lack of management attention, even see that the problem is moved somewhere completely different. The other point is your ERP systems. Please don't try to use your ERP systems to find your bottlenecks. They will never find them because you've taught them not to. You have budgets every year in where at the end you've convinced yourselves that you've balanced your facilities, your organizations. That's what a budget is for, right? There are 24 people over there because 26 will be too much and 22 is not enough. And my ERP system confirms that with my workload calculation. Okay, it so happens it's wrong. Okay, you're just justifying a budget with lots of false figures and data that's wrong. Okay, so don't try and ask your computer where your bottlenecks are. It will tell you that you're nearly balanced. Okay, and what's worse is that in the modern world, more and more operations are getting to be indirect, right? And often these indirect operations are not managed as capacity, and that's the case of anything to do with quality in particular. And so the data won't even be in there. Okay, so go out to the shop floor and think about it, and don't ask your ERP. It won't tell you where your bottlenecks are. Another point, if I can say the same thing in a different way, is very often when people tell us where they think their bottlenecks are, it's nearly true, okay? But it's just 1, 2, 3, 5 years out of date. They're telling us where it was, not where it is today, okay? And their mindset and their look on their company is just a little outdated. And it's never completely wrong, but often it's just no longer true. It's moved on. The bottlenecks moved to somewhere else. Okay, just a bit of a short warning list of the sort of things that might have moved it. I put it in red: new quality requirements. Whatever your business is, the requirements in terms of quality are increasing year by year, whether it's in pharmaceuticals, in aeronautics, or wherever. And as a result, the work to be done to ensure that quality is increasing very regularly. And we're often finding that, in fact, the means you've given yourself, since you might consider it a cost and not a value-added function, have not followed. Okay, and you'll find that your quality organization as a whole, whether it's officially that the organization, the quality, or the people doing quality throughout your system, will end up with too much work. Okay, so check that your quality has not become your capacity constraint. Another classic is regrettable cost-cutting initiatives. Okay, you want to save some money on your overall costs because you're not making enough money, and so you reduce the headcount over there from 18 to 12, and you just went a bit too fast and a bit too far, and under 15 you've turned it into a bottleneck. Okay, you were trying to save $100 and it cost you 10,000. New technology, of course, new machines coming in, it's getting more and more faster and faster. That's just going to, the pace of that new technology arriving is just going to increase further and again and again. So it's going to be new machines coming in, new strategy, new strategic decisions, new raw materials. We had an example. New management with new rules. People can just decide by doing more subcontracting or less subcontracting, or going from 2 shifts to 3 shifts here or whatever. They will change the distribution of capacity, and they can create or move the bottleneck. A new competitor, new regulation, or whatever. So make sure that when you're looking to try and identify your bottleneck, you're up to date with where it really is today, and you're not talking about your company 2 years ago. Capacity constraints in projects. Our work in projects is nearly all in new product development, so I'm not going to talk about the construction business or other areas. And just to make it clear, as far as we're concerned, there are 2 different dimensions or 2 different types of constraints in project management. And this is the theory constraints way of looking at things. There is the critical chain, the close cousin to the critical path, and that will be the constraint of an individual project. Okay, the shorter that is, the faster the project will be finished, the more performance you'll get. And then if you're in a portfolio environment, such as developing new products with your engineering department or something like that, you have a capacity constraint that will be the resources somewhere in your system, part of your resources. And so we've got the sort of cross effect where you've got the constraints of each project going through a resource that is a capacity constraint. Now, if the data in manufacturing is sufficiently wrong to be not useful to make capacity load calculations, the data regarding the project world, you don't even need to waste your time looking at it. Okay? It is so wrong. How many hours will it take you to have a good idea? Will it take you 10 minutes? Will it take you 10 years? How many hours? Okay? How many hours will it take you to prove a concept? How many days will it take to develop a new prototype with a new technology? Nobody knows any of that. So the idea that you might believe that you've balanced the workload and the resources correctly with regards to what you have to produce, and then you haven't even discussed the product that hasn't arrived yet and which the marketing is going to ask you to develop in 2 months' time with a completely new idea that's off the shelf, not off the shelf. There's no way, okay? So don't even bother looking at the data. Well, that's important, especially when I add that the past is not at all a good representation of where you are today and where the future will be. And to summarize it, what is troubling is that very often people are trying to develop today's products or tomorrow's products, okay, with yesterday's resource pool. They have the people that they hired, and they were they were the right people to produce the products that you produced 5 years ago or have been producing. But it's quite likely that things have moved on, and that for the products you're starting to develop today, you don't have the right resources. Okay, so watch out for all the new things in your business that are often exploding, right? Not just emerging, they're disturbing your what you thought your job was. Electronics, of course. Regulatory, because I mentioned it, the more and more quality and regulations that go with it. So do you have the right staffing and the right competencies to deal with regulations? For instance, if you're in drug development throughout the world, are you really on top of the ball with regards to the difference in regulation between Europe, between Brazil, between Japan, and so forth? Software development, I mean, there's so much software now, even in a toothbrush, that do you have the teams to do it? And quality management, which I've already talked about. So, to conclude, forget the data. All that data is wrong. It might be useful for something else, but it won't help you find your constraints. And beware if the bottleneck you think you have is too good to be true. Okay, we're finding regrettable bottlenecks all the time. Okay, so if you want to tell me that your bottleneck is this nice, expensive machine here, right in the middle of your factory, I'm going to be doubtful. We're finding bottlenecks all over the place, never where they should be. Okay, so beware you haven't fallen asleep with the idea that that's where it should be, and in fact it's somewhere else. Okay. Now that might sound disturbing. I'm lost. Where am I going to find it? How am I going to be sure? How do I know if I'm right? And so forth. It's true. It might take you a while to find it, but be reassured with one simple thing. Once you've found it, it's easy to make sure that you're right by testing that idea. Normally, once you find the constraint in your system, everything starts making sense. Okay, it broke down for 2 weeks, sales dropped. Okay, it had a fantastic time, sales went up. Okay, and often you'll find the performance of your bottleneck, as I mentioned in one of the previous examples, you can perfectly correlate it to the performance of the company. Okay, other obvious stuff is the work piled up in front of it. Yes. Okay. Do people come screaming to that machine or that area all the time saying, I need my product, I need my thing, we're late? Yes. Okay. So it might be difficult to find in today's environment, but once you're right, test your hypothesis, once you've got a hypothesis, test it, and you'll see it'll be very easy, because suddenly everything will make sense. You'll just say, it's obvious, why didn't I think of it? Okay. Now, I said it was good news, and why is that good news, that you don't know where your bottleneck is? Well, it's very simple. You find out where it really is, okay? You've probably been neglecting it, okay, because you didn't think it was the bottleneck. So it's not working at its full pace at all. And all you have to do then is take care of it properly, probably with just a bit of management attention, very little money, and suddenly it will give you 20, 30, 40% more. That will mean you get 20, 30 or 40% more sales. Yes? Okay? So bad news is you missed it up till now. The good news is if you find it, it can make a very, very significant difference very, very quickly. Okay? Thank you very much. Any questions?